class, you already finished the questions, is it?
Yeah.
Okay, so let's see the 5.2, damping and resonance. So in the let's see the damping in oscillating system. So damping is okay for in an oscillating system. When something the wave is moving like this, right? Standardized if he doesn't undergo damping, the peak it will always maintain at the peak and lower peak, the upper and lower peak, right? However, normal way is not like this. Normal way it will going lower and lower and lower until it stops. Okay, like if you swing the pendulum, you let it swing. After some time, it will eventually stop. Correct. So why this happened? This is due to damping. Okay. So now, in the oscillating system, does not continue with the same amplitude indefinitely, except when the system is oscillating in a vacuum. We start with the damping first. Don't copy the right side first. So for this one, you will undergo damping for oscillating system. Okay, so damping is a decrease in amplitude of an oscillating system when the energy is drained out as heat energy. Okay, like there's a loss of energy due to the resistance sometimes. Due to the resistance, so it converts from energy, kinetic energy or potential energy to the what I call to heat. Okay, so the amplitude will gradually decrease and eventually will become zero when the oscillation stops. So the graph that shows damping is like this. You see the amplitude is going lower and lower and eventually go to zero. Okay, the displacement as well. Displacement time graph will become like this. Like I show you just now, the red color one here. Okay, like this. Okay, so it's like the wave is going lower, lower, and lower, and until it stops. Okay, all right, got this down. Only the damping, this one and the damping first. Don't start the resonance. You know, this road of the house. That day, I think there's an Indian family. They are having what kind of wedding or some or the what you call or because of the what you call the funeral. Do you know?
No, I didn't see.
The
Kema.
the Kema one, yes.
Did they put white color only or colorful?
White.
Only white.
I think it's funeral.
Funeral.
Normally funeral, right? Because I never experienced the Indian funeral because I know Malay one pretty easy one. They will be that on that particular day they will land out and go and bury in the what you call in the ground. But I don't know the graveyard. But for the what you call for Indian one how
Can you bury the graveyard or can
burn
also?
Mostly are burn or
mostly they choose to burn.
Oh. I got a call now. Hello. Hello, yes. Oh, nowadays they all talk that I'm very rich. Everyday personal loan. Because what you call our central bank, bank negara, they have already dropped down the interest. They dropped down the interest because they want. You see, our money nowadays are going up. Ringgit is looks like getting strong, so they are trying to drop down the what you call that, the loan interest, so that more people will try to get more money and invest, so that more money can be running to
Today, Anwar meeting or something, Anwar will talk. That's what they all say.
they can't every country is dying nowadays. So don't be too trust about what our PM said. He can't do anything nowadays. uh, he said he is getting some investment, potential investment, and it's always potential. Uh, they can't do anything because this is not his fault as well. The whole world is getting downward. Our country now is actually still okay compared to others. We are actually still okay. We didn't have a very big we call the inflation, or we didn't have a very terrible we call the what we call it war. Huh?
War.
No, war is still war. We are not happening as well, but the what you call that, the opportunity for getting a job is still okay. We are not that hard actually. If you're looking at China, they are actually, although they have a very bright side, but they have their black side as well, where nowadays, especially the big city like Shanghai, like what you call that, like Beijing, I heard that there are lots of companies are slimming down. So got many of people who are getting fired, or getting or their contract are not renewed, especially those high management, because they have the highest pay. I stop you one, okay, is your salary is even bigger than maybe 4 to 5%. So nowadays they are trying to slimming down the management, so that's why they have a problem. If you see US, it's even worse. United States nowadays is where it's worse. One of the worst country nowadays in terms of economy or financial nowadays. Well, Donald stupid Trump. We can't do anything about it. It's getting crazy already.
The graph is right drawn.
Yes. You need actually the displacement time graph is the most important one. But you need to draw of course, you need to draw both so that you can remember . Done, huh? All right, now let's continue with the next one. Okay, the two types of damping. First, the external damping. So this is caused due to loss of energy. This is to overcome the frictional force or air resistance. While the internal damping is due to the loss of energy by stretching and compression of particle in the system. So this one, the internal damping normally are like the spring, for example, okay, which is normally for the what you call the horizontal one, okay. So, and this pull will cause the amplitude and energy decrease, and the frequency is, but at the same time, the frequency doesn't change. You see, the frequency is still constant. Okay, all right, do this now. Hmm? All right. Wait, huh? All right, now let us see resonance. Now, resonance is occur when a system is made to oscillate at a frequency that equivalent to its natural frequency by external force. So the resonating system oscillate at its maximum amplitude. Means that when both are oscillating at the same frequency, so their phase at that particular time will be the same, correct? So when these two combine, it will become the amplitude will be the sum of these two. Can you understand? Okay? Can I? All right. Of course, it doesn't just add. Sometimes they will also minus each other as well. Later we will go through together. It's that they're already vibrating, but I'm giving an external force on that system. It's already vibrating, but I give it external forces so that either it will increase the vibration or yeah, we will like compensate each other. Okay, can you understand? All right, jot down this. This is how resonance should be like. But of course, your answer you cannot say compensate or something like that. You should write according to this. So the main point here for this one will be the system that oscillate, okay, that is made to oscillate at the natural frequency of the system by external force. So two things. Oscillate it at natural frequency. Natural frequency means that the initial frequency, and by external force. Because it's like okay, okay, you are playing the jump rope. The jump rope, right?
Yeah.
Normally one people hold, one people pushing. Then suddenly you also want to pushing. So two people pushing, the vibration now will become bigger. Something like that. This is resonance. Done, huh? All right, now let's see some effect from this resonance. First, for the effect, we're talking about the effect. So the tuner in radio or television will enable us to select the program. Okay, so how it looks like is actually when we receive, I mean the receiver. Okay, we are trying to receive it. How we make sure why there's a when there's a receiver, the image will look clearer because your receiver will resonance the wave so that the wave becomes stronger. Amplify lah, it's like an amplification. It's an amplification. It's actually we amplify it so that we can select the program and makes it looks clearer with the what you call with the receiver nowadays. Like the Android, you have seen the one before Android. Before one is like around 480 480 pix 480 on your phone. Check 480. Like your phone maximum is normally is 360 man, yeah. Then 480 man, normally 480 unless you select to 720, correct? But if using the old type one, only 480 maximum. So try to imagine 480 and make it to 30-inch screen. It's like your face got lots of dot the very old PC game the very old one You know the very old PC game like the LED alert the video looks very lousy, right? That's the thing. So that's why. Okay, the resonance is achieved by the frequency transmitted by the particular station selected. That's why a strong electrical signal is produced. Okay, the receiver is receiving the amplified one. So this process we call amplification. The other one, okay, it can sometimes it can also cause damage. For example, a bridge can collapse when an amplitude of its vibration increase as a result of resonance, like the Tacoma Narrow Bridge in USA in 1949. Okay, this is due to the wind. The action of wind caused the bridge to vibrate at a large amplitude. Okay, so when the wind blow, your bridge is already self-vibrating in that phase, so it might collapse. So that's why people say, don't jump on the tall building together. If no, the tall building might collapse. Okay, this is due to resonance. Right, that is how. Okay, done. Let me know. Huh?
Uh,
Done. Ah?
Acknowledge.
Okay.
Should I?
Done. Huh? All right. Now let's see the some word. Okay. So for external force is the force that apply to oscillation system to enable the system to oscillate continuously. So force oscillation is an oscillation system that oscillate because of the periodic external force that apply on it. Means that periodic external force means that we will add in the force into the system periodically, maybe every 10 seconds, something like that. Okay, while the natural frequency is the frequency of the system which oscillate freely without the action of an external force. Okay,
Yeah.
all right, jot this three. Done, huh? All right, now let's continue. So let's see some questions here. Now, the pendulum B is oscillated by using an appropriate physics concept. Explain what will happen to the state of oscillation of other pendulum after a while. So when you oscillate B, so they will. Okay, so the what you call that, the pendulum B will oscillate and then will transfer the energy to other pendulum. And you see, length of B and length of D is the same. So the frequency for B and D will be the same. Okay. So the what you call that, the pendulum will undergo, this D will undergo resonance, and pendulum D will oscillate with maximum amplitude. Okay, I can understand.
Okay.
All right. Now there are some notes that you have to be take care of. One is the frequency of the pendulum is actually depending on the length of the pendulum. And two pendulum of the same length normally have the same frequency and period. Okay, so jot this down. The questions, note, and this one. Okay, now let's continue. Okay, so let's see the graph. So let's see the okay, so let's see the reflection of waves. So let's see what is called the definition of wavefront. The wavefront is actually the locus of point which vibrate in phase. For example, you see these are two wave, same two wave. So you see on the same phase, this is called wavefront. Same phase called wavefront. Same phase called wavefront. Okay, C is crest, T will be the trough, which is the upper amplitude and lower amplitude. So it's the point that of locus that the wave vibrate at the same phase. Same phase is like okay. It's like okay, this is the first one. Okay, so like when on this time, they also so you see it's the same, right? So these two are the wavefront like that. Can you understand? Imagine that this is the 3D and they are moving side by side. So same phase, then this line is the waveline. Okay. All right. Okay, you jot down this one first. The first one first.
Yeah.
Done, huh? All right, now let's continue. Now let's see the types of we say the types of wavefront. So this one is a circular wavefront. Circular wavefront are normally like this. Okay, it's like when the drop of water drop on the water surface. So it will create like this, right? This is the wavefront. The round thing, the round thing is the wavefront. Or the plane wavefront. Plane wavefront is like when the sea wave comes in, it's like a straight line going horizontal, right? So this is the plane. The sea wave is the plane wavefront. Okay. Now, so the direction of the propagation of the wave is perpendicular to the wavefront. Normally, it's perpendicular 90 degrees. Now, for the refraction of wave, it occurs when an incident wave strikes a reflector and undergo the change of direction in what you call of propagation. So normally it occurs to water wave, sound, light wave, and also electromagnetic wave. It's like this, like light wave, hits in the reflector, then it will the direction of the propagation now change. Okay, right? Now, so with this, we start with the law of reflection. With this, okay, the law of yes.
The,
Mm.
the blue color one, right?
Yeah.
No, the occurs to water wave.
Mm.
That one I can't understand.
Water wave is like I said, when you drop a drop of water, you will see a round thing like going spread, right? But that round thing is actually the wavefront.
So that also big.
Yeah. As you see, when something push in, then it vibrate, then it's called oscillation system.
The sea wave.
Yes, it's called, and sea wave is this one.
Yeah.
Plane, these are like the sea wave, plane wavefront. Okay, of course, you don't check, you will say that Manada, the seaside one is Bangkok one because the seaside is already in shape. If you go to the deep sea, then it will be straight one. Okay, like your light as well. Your light, actually, there's a wavefront. Okay, maybe I can show you something like that. For example, this one I have to show. I cannot show online, so we have to show this. Okay. This one. For example, you see, when I go in here, you see it's like a round, and then a little bit darker round. Yeah. It's like a ring, right? There are lots of ring, and the light intensity is going darker and darker. Yeah. So when I going up there, so you see it's still round. So this round here, this round shape here, the bright side is the wavefront. The darker a bit, wavefront like that. This is why light is also considered. This can be, used as wavefront. Then of course your electromagnetic wave. Okay, electromagnetic wave, easy, like electric. Your electric is going sinusoidal, right? Sinusoidal, of course, is wavefront. There's a wavefront there, okay? So now, from the reflection, okay, so for the law of reflection, so I is the incident wave, which is the coming one. R is the refracted wave going up, the angle. Okay, the angle of incident and the angle of refractive, and this is the normal line. So this shows that the incident wave, refracted wave, and normal lies in the same plane. 1, 2, 3 in the same plane, which is perpendicular to the reflecting surface at the point of incidence. This is the point of incidence. Can you understand? Yeah. All right. So drop these three. And for this one, the hukum, this law of reflection, maybe you have to use this one. Okay. So, excuse for one. You look so tired, why?
After this, also, but tuition is
Huh?
today is good finish 2 o'clock.
Oh.
Got extra class.
Oh, you guys got extra class, ah?
No, for me, because that day tuition teacher didn't come.
Oh.
She had extra class.
Oh.
Okay. After that, straight away to come here. After this,
Oh, I see. So now let's see the next one, the characteristic of law of refraction. So first, like I said, I normally is equals to R, and the wavelength, frequency, and wave speed does not change after the refraction. The energy are totally refracted. The assumption here is there's no loss of energy. Okay, and the direction of propagation of wave change when it's refracted. The direction change only the direction is changed. Okay, can I? All right, jot this out. Oh, you still got a class later. Oh yeah, you got a class around 9, right?
7.
7:30. Because I thought at first you guys said only me, my class, and the next class only, right? Normally.
Today,
Today is a special one,
yeah, today is supposed to be the bio
Hmm.
and teachers class. Physics class.
But because of your tuition teacher is not around last time, so it's a replacement,
Yeah.
I see. Done, All right. Stop here for today, Okay. Because this one need to explain one by one. So I think I stop here for today. Okay. Any questions? No, All right. I think I stop here for today. So we shall meet each other on next week.